Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my pleasure and delight to welcome today's guest, Pramod Pillai. Pramod is an excellent material chemist and also does some very interesting stuff at the interface of physical chemistry and catalysis and various different research areas. Pramod also actually has a fantastic lab, which he calls his Nano Alchemy laboratory, where there is some fascinating work which is going on in his research group. And Pramod is an associate professor of chemistry at the Indian Institute of Science Education Research, Pune. And he's my very dear colleague and also a fantastic person. I'm delighted to actually have Pramod on Pratidhwani. Welcome to Pratidhwani, Pramod.
Thanks, Pawan. Thanks for all the kind words about my group as well as the research. And thank you for hosting me in Pratidhwani. So I had, as you know, I have been watching this podcast for a long time, and I'm very much impressed by the different, concepts and different things that are discussed in this platform, which is related to a researcher as well as research. And most of the things are not covered in an open community. So, I should congratulate and as well as thank you for coming up with this nice idea of humanizing science through your podcast. And I'm delighted to be today's guest.
My pleasure. My pleasure. In fact, the point of kind of reference for us to also have this discussion is science need not be just part of our laboratories. It has to go beyond the laboratories. And I have been actually doing this, and it has been a great pleasure for me, and also a great learning process. So I'm very glad that you're joining. So as always, we will start with the question of how you got interested in science, Pramod. Tell us a little bit about your background. Where were you born, and what was the kind of upbringing you had?
Okay, good. So, I'm basically a native from Kerala. So I was born in a town called Cherthala, which is coming under the district Alleppey, so which is called Venice of the East. So a lot of backwaters, boatings, seafoods. So that is the area that I represent. And so to tell, how I got interested in science, it's a big story. And I think, this will be a story which will be different from many of the scientists that they have. So I must start by telling that, science was not my first choice to pursue as a career in my life. And but later I realized in my life that, the interest and the passion for science was always in me. It took me a lot of time to realize that, this is the thing that I wanted to do. And the reason for this late realization is connected with my family background, because my father is a retired army officer.
Wow. Okay.
So when I was during my childhood, he was actively serving the army. So we were at different parts of the country. And so basically, I was, so most of my childhood was inside the army stations. And whatever I was exposed to was majorly the army life. And I'm talking about 80s and early 90s, right? So there you don't have this kind of social media, the networking, connections and everything. So I was predominantly within this army station. And all the friends that I had were also from army family. So whatever we are talking, whatever we are seeing, whatever we are discussing is all about army related stuff. And so I was also in Chandigarh, and at that time, when it was a peak of insurgency in Chandigarh and Punjab, and we used to hear a lot of stories. Some people tried to attack our station; they were caught. This fancy stuff that I was used to hear. Okay, so and so my life was completely influenced by the army life. Childhood especially. So I used to see my father getting dressed up with this attractive army uniform. He used to go every morning, early in the morning, and so I was completely impressed and motivated to join army. So that was the thing that I remember from my childhood. Okay, so there was no other profession or no other thing that I was aware of, and I also didn't want to do that because this is what I am seeing. So I wanted to pursue a career in army, and I was pretty much focused about that also, because we are well informed the different ways through which you can get into the army, being in an army family. So I was very much aware how to get into it. So my target was all to achieve those stages. So that is how my childhood was going on. So for me, 10th, 12th, degree, these were all different checkpoints for me to get into the army. So that was my perception at that time. So I didn't think that, I will be making a different career out of my education. So I wanted to graduate 10th so that I can apply for this stage in the army. I should graduate 12th so that I can apply for that stage of the army. So that was my ideology at that time, okay, about science. But that doesn't mean that I was not focused about the education. I was very much interested in the subjects that I was learning, especially the science and the math subjects. And I was pretty much a good student at that time, till 12th standard, I was a pretty much good student. And I was also actively involved in sports because, this is one criteria that you need to have to go into armed forces. So I was very much actively involved in various sports activity. In fact, I was the team member of school football team, 4x400 relay team and athletics and all those. So I was active both in the studies and the sports thing. So that was my childhood and that is my background. So then what happened is that, it was the 8th standard at which I attempted first to get into the army. So there is a school called, RIMC, which stands for Rashtriya Indian Military College. So this is located in Dehradun. So I think this is probably the earliest age that a person can go into the army.
Okay. So right at the school level.
At the school level. So if you qualify, you can do your 8th to 12th in this RIMC Dehradun. And after that, after 12th, you directly get inducted into this National Defense Academy, which is there in Khadakwasla in Pune. So they enter into the army. So that is the route. So, but it is very competitive exam because to give you a feel for this competitiveness, only one student per state can get qualified. So that is the level of competition. And obviously in that year, I was not that student from my state. So I could not get into the RIMC. And then I continued in the same school that I was doing my 7th and I continued 8th and I reached till 12th. But still my passion, everything was about joining army only. And then when I reached 12th, so you have the next stage to enter into the army, which is the National Defense Academy in Pune. So I wrote the exam multiple times, but somehow I could not clear the entrance exam. So I lost all the chances and it was clear that I may not be ending up in NDA. So the next thing is that I have to move forward from 12th. So now, as you know, during our age, this was, during our time, it was like medicine, engineering was completely, everyone was interested in that. And all my friends were ongoing coaching and everything. So I also wrote that exam, but I was not that interested in doing engineering or medicine. But since the flow was like that, I also wrote the exam. And I got a decent rank, but that rank was not enough to get into a good college, engineering college, under the merit seat. And at that time, the number of engineering colleges were also less when compared to now. So I could have got in under this management quota. It was too expensive for us to afford at that time. I also thought that, okay, so some natural screening has happened. So I will not go because of this financial thing. So let's pursue in science. So when I thought about science, mathematics was the most interesting subject for me in 12th. And nice. I believe that I was very good at math. And I wanted to pursue a career in math. So I thought that, okay, chalo, math. But still the army thing was there because I know that if I get a degree, I have another chance to appear for the army. So I just wanted to have a degree. It doesn't matter which subject it is. But somehow I was more inclined towards mathematics. But unfortunately, I was misinformed that, it is difficult to have a career in math. That is what I was misinformed. But later when I started my research career, I realized that, math is a beautiful subject and I should have done that. But at that time, there were not many people to show me the importance of math. And they told that math is like a supporting subject. So, please take physics, chemistry or something, and then you can do math in that. That is the suggestion or that thing I got from my teachers. So the next thing was physics. Because, the second interesting subject for me was physics. And there are multiple reasons for that because I liked physics from 12th and optics, especially the optics part was, very much interesting. The teacher who taught me was, the focal length and all those things, the focusing part and everything was virtual image, real image. So those things were fascinating for me. And so I decided that I should do a BSc in physics. And the other reason that I wanted to do BSc in physics was my brother was doing a 3rd year BSc in physics at that time.
Oh, so, elder brother?
Elder brother.
Oh, okay.
He used to talk about this college life, physics people are, the genius, was kind of impression he used to give it to me. And he used to buy a lot of books, even though we could not afford at many times, but somehow he used to manage money and he used to get a lot of books. And in his room, I can see all these books stacked away. And at the cover page of these books were so attractive, optics image, electronics, so that fascinated me. Then I thought, yes, physics is what I want to do. And I applied to all the colleges and I had a decent mark in my 12th. So I could get in most of the colleges that I applied. And in fact, I got in the same college where my brother was doing the third year BSc. So I selected that, okay, I will go to the same college because I have a senior in the form of my brother. So, it is a good start, no one will, no ragging or anything like that. It will be like a good, no problems in the beginning. So I thought that, chalo, wahi pe chalte. That was my idea. But around that time, I came to know that, there is a new course that the government of Kerala is trying to introduce, which is called as industrial chemistry.
Mm-hmm.
And they call that it is a self-financing course, it is a professional course, it is a job-oriented course. So this is a time of 1998. So that is a time when in Kerala, the government started for this job-oriented course because everyone could not get into engineering. So they thought that, there can be something in between science and engineering, which will have a lot of job prospects and everything. So I was attracted by that. And that was not in my hometown. It was in Cochin, which is something like 40 to 45 kilometers away from my home. So, and the other part was that you have to write an entrance to get into that course. So I thought that, okay, it will be a little bit more competitive and challenging. So, chalo, we will attempt that. So I gave the entrance exam and fortunately I qualified that entrance exam. And as I have told earlier, I have written so many entrance exams to enter into army, which I never qualified. And this was the first entrance exam that I qualified. So I was so happy. And I was that much happy that I forget the passion about physics and I opted to join industrial chemistry. So I hope you understand the background,
Yes.
how I took that decision, And so I joined industrial chemistry in Cochin. And but still my ambition was still to join the army. So I wanted to get a degree and then pursue for the army. And when I was in my final year of BSc, my elder brother got into the army through the Combined Defense Service. And he went into the Indian Military Academy at Dehradun. And so then that was a big boost for me because then I was 100% sure that, okay, I am also going into the same thing. So no one can stop me, this is my thing. And as a family, we will be in the army. And so that was the thing. But, and I wrote this Combined Defense Service exam multiple times. First couple of times, I think couple of times I could not qualify that. And I think the third time I qualified this entrance exam. That was the second entrance exam that I qualified. And I was so happy. And then I went to this interview, which they called as staff selection board, which is one of the toughest interviews to qualify in India. But unfortunately, I could not qualify it. And that was a moment when I realized that I have a medical issue. I have this problem of color blindness.
Oh.
So I didn't know that. It's not a common thing that we come to. So during this test and everything, I came to know that I have color blindness, and so that means I am medically permanently rejected for armed forces. Even railways or everywhere, I think you need to have a good eye, So that was a disaster for me that time, and it happened around first year of my MSc chemistry. And it was a complete shock because, as you can imagine, from my childhood, this was my dream.
Yeah.
And I have been planning my life for that. So it was a complete disaster. I was completely down. I didn't know how to come back from that, and I was staying in the hostel. So, and my classes were getting affected. I could not focus in my theory classes as well as in lab because in masters, you have so many lab courses. I was making silly mistakes, the teachers were shouting at me. And I am doing the MSc at the same place where I did my degree, BSc. Teachers knew me. And one of the teachers noticed that, I have I'm a little down and I'm disappointed. And he came to me. His name is Dr. Joseph John. So he came to me and he asked me, what is the problem? What is happening? You are not like this. You are a really active person. Now you are down for a couple of months. Then I told him all the stories that, this is what has happened. And unfortunately, he could not tell anything because, for example, if you fail in an exam, a teacher can say that it's okay. Next time you can come back. But here there is no next chance because it's a permanent rejection. So I cannot. So he also didn't know what he should do. So then he asked me the reason that why you wanted to join up. What was the thing that attracted? Then I told all these things, my childhood things. I told whatever I have discussed now, and then I told that apart from that, I like this army thing because it's about group. It's about activities in a group. So that is what the profession that I am looking for. I don't want to be in a profession where you are the only person doing everything. So I wanted to be in a group so that we develop as a group. The leadership quality should be an important criteria for a job. And I didn't want to be in a job which will get very routine after a few years. So I wanted challenges, excitement at a daily basis. And this was a profession which I thought was going to give me that. Then he told that, okay, if these are your criteria, then research is another option for you, because there also it's a team. It's not that you alone are doing, right. You are working as a group, you are learning as a group. So that was the first time that it came to my mind that research could be an option.
Nice.
In me as a science. It was in the end of the first year of MSc. That is how but still I was disappointed. It's not that the army thing went out of me till today. I must say that till today it has not but yeah, but then what happened is that in the second year of MSc, there was a team of scientists who visited our college from RRL Trivandrum, like Regional Research Laboratory Trivandrum. Now it is called as NIIST. The name has the CSIR lab. So it's the team comprised of Professor M.B. George. You know him very well. And Professor George Thomas, Professor Ajay Ghosh, and one organic chemist, Professor Vijay Nair. So three of them gave a scientific talk. And at that time, I didn't understand what they were talking about, but it looked very fantastic. And it was clear that they are doing something serious in their lab. So that impression was there. And they were showing the photos of the students that, they did this. So I was getting impressed that, okay, it's a teamwork that they are showing. And this professor is just representing a group. So that was first time that I realized that, research is also a kind of a teamwork and all those things. And I was one of the organizers. Since I was a senior MSc student there, I was the organizer of this, one of the organizers for this event. And when I was looking into this, when I came into this conference hall, I saw an old person sitting at the last row. Okay, and adjacent to that, there was a seat available. So I just went there and I sat there, and then I just interacted with this old person. So he introduced himself as Professor M.B. George. Okay. At that time, I didn't know who these people are, because the exposure of scientists and science in a college that I studied, it's minimum exposure. We don't know any of these things happening outside the college. So there was no change in my facial expression. I was like, okay. Then he started to explain. Okay, he was one of the three research, faculty members who started the chemistry department at IIT Kanpur. He started to talk about Professor C.N.R. Rao, Professor Narasimhan, and all those stories. He started to I realized that, man, so the man who is sitting adjacent to me is a big man in science. And he told he did postdoc with Nobel laureates and everything, So then I told, oh, what a... So then at that time, he asked me, what are your plans after MSc? And since the scientist is asking the question, the answer was obvious, that I want to continue in science. Then you told, for that you have to qualify some exams, and national level exams are there. Then I told, yeah, I know I have to qualify UGC NET. And not NET, JRF, CSIR JRF. So that was the first time I heard about JRF. Till that time in our college, people only talk about lectureship, because people go as a teacher. They don't think about research as a career that much. So that was the first time when I came to know that JRF, yes, JRF. Then he told you should do that. And he told that after that, the talks were over, and over the tea, he introduced me to Professor George Thomas, Professor Ajay Ghosh, and Professor Vijay Nair. We all had a chit chat. And then at that time, Professor George told that if you want to do the MSc thesis, you can come to our place and we can try to accommodate a place for you. But then in our colleges, there is no dedicated time for MSc thesis. So you have in the college itself. It's like not short, like 1 month duration, and you have theory courses along with that. So you cannot be away from the colleges. Now the situation has changed. And so I told that I won't be able to come because of this official restriction. Then he told, okay, if there's a chance, just contact us. That was the first interaction that I had with a scientist, a true scientist. And then the course was over. And then what happened is that my MSc final exams were over. And around that time, we had that CSIR exam. So since, people are talking about CSIR, my teacher also told that, you may have a career in research, so try to write this exam. And Professor George also mentioned about this. So I thought of, and I was fresh from my MSc. So most of the topics were fresh for me. And I wrote the exam. And as you know, during our time, there were two papers, right? Paper 1 and paper 2.
Yeah.
You have to qualify the paper 1 separately. All those things were there. So, and it went well. And then, my exams were over, my viva was over, and I was waiting for the results. And at that time, one of my seniors was doing PhD with Professor George Thomas at RRL Trivandrum, and he was very close to Professor George. So over one conversation, Professor George just asked his name is James, that, when I came to your college, there was a student who interacted with me. He expressed the interest to do science and all those things. What is he doing? So he remembered it, after, this is after 1 year or so. So, and then James calls me back and he tells that, Pramod, did you have an interaction with Professor George? And also, yeah, I did. So I just interacted with him, but he remembered it. And then I thought that, okay, then I should give it a try. And during that time, many of my friends were going for B.Ed and they were going for small industry jobs. And it was too early for me to take up a job because, I felt that it is too early. So then I thought, let's try and go and meet him. So I went to Antrim. I met Professor M.B. George, and he again introduced me to Professor George Thomas. And he told that there is some vacancy, project vacancy is there. Since you don't have MSc, we won't be able to take you as an MSc graduate. It will be just based on the BSc. It's like an ad hoc appointment or something like that. And once you qualify the CSIR and MSc, you can be converted into PhD. That was That was the offer that he told, and I told that that I didn't have any other option. Nothing was available to me, and that ambience also I liked. And then I told that I will join after 1 month. And I went after 1 month. I went to RRL Trivandrum, and the day when I entered RRL Trivandrum, around afternoon, soon after lunch, I still remember. So soon after lunch, the CSIR results came. I qualified the CSIR.
Wow, what a coincidence, huh?
Yeah, it's a coincidence. Yes, the decision that I have taken is correct. No turning back, So that was, I would say nature's presence was there, and it was then it was clear, and I decided to continue with Professor George Thomas. The initial months were very hectic because this was not the area that I wanted, but soon I started to learn science, and my passion grew from that day. So that is how I came to science.
Wow, wonderful. This is actually great description of how things actually happen in a serendipitous way, because a lot of things are not planned. This is a very important point what you're mentioning. And another aspect, Pramod, it looks like there was reasonable support from your family, if I understand correctly.
Yes.
Because sometimes for people who have gone through, it is a trivial thing.
Yes.
Whereas there are people who have not faced this particular advantage, and one can see the issue there.
Yes,
how was your family kind of looking at what you are doing? Because you also mentioned that you did not take the option of going into engineering, but you went to the sciences. Because like any place in India, most of the time they would want their children to go into engineering or medicine. Unless the parents have that notion that science is important. Can you tell us a little bit about the kind of support you got from your family?
So the support was tremendous, from my parents and even my brother, I would say. So the thing is, since my family is also is an army family, so not that well aware about engineering and medicine. Definitely they are aware of it because they know about it. But other than that, science opportunities in science and all, they are not aware of this. So from their side, I didn't have any compulsion that, I should do this, I should do that, or thing like that. So when that engineering thing came, they told that if you want, you can go, we can take bank loans and blah, blah, blah kind of a thing. We can adjust. But I was also not sure that should I do engineering. So I told them that don't worry about it. My teachers have told that science is also interesting. And my brother was doing science at that time. So that was a very good support from me, and they really supported me because since I told you that I did BSc Industrial Chemistry, and this is a self-financing course. So the fees is much higher than a normal BSc Chemistry course. And for us, it was little difficult to afford at that time, but my parents were, very supportive. They financially supported, and I was staying in the hostel. That again added to the expense. So, but the family support I got was tremendous from my parents. And after my third year, my brother went into the army. So he also started to get a fellowship. So he also financially supported me to buy the textbooks and everything. So the support, without their support, I would never have done this. And even after the stage when I realized that army is not my career, when I discussed with my parents, my father was very, very, very generous, and I thought that he would be unhappy because as an army person, he would have expected both his sons to be. So and one son went. So I thought that he would be disappointed, but he supported me a lot. He told that you have done what you could do. It is this medical situation is not in our hand. And I realized that the problem that I had is a genetic problem. It's not because that I watched the TV a lot or I was using my eyes. It's a genetic thing. I had nothing to do in that. And so he that support was that 1 year or something, that support that I got from them during my MSc. It was amazing. I wouldn't have crossed it if they wouldn't have supported. Because my biggest feeling was the guilt feeling that I am not able to reach or to do the things that my parents also had it. So that was my biggest guilt, other than my own ambition. This guilt was also there, but they were very instrumental in removing that guilt from my side. And that support was amazing. And once you go for the PhD, as you know, you are self-sustained, and then there was no issue. But those 3-4 years, the support that I got from them is immense.
Yes. See, that is another point. One more thing I want to just elaborate a little bit and get your input on. It is not an easy thing, because if you figure out that there is an element which is unusual, and second thing is it can actually hamper your career, it would actually be more kind of disappointing, because there are expectations, as you mentioned. There's also a background for you to get into that. It also means that there is some kind of resilience, some kind of process you would have gone through, which would have given you more confidence and also kind of courage to pursue. No matter how supportive the environment is, you will also have to then talk to yourself and really come to a stage where you are facing the world without having to feel guilty about something which you really did not have control over. How did you cope that part of the life, Pramod? It's an important thing, because there is a lesson for all of us there in that sense.
So during those days, friends, since I was staying in the hostel, that also helped me a little, because after the classes we are all together. We will be doing our own hostel stuffs, the so-called hostel stuffs. I was also, so they dragged, and everyone around me knew that this was my ambition. So they were also helping me to come out of this disappointment. So that hostel life was very, I would say that was another important factor which helped me to come out of this disappointment without much impact. And then, as you told, you have to talk to yourself, right? So it's again very important that you have to tell that, it is not because of your thing that it has happened. So you have to move forward in life. And I would say that I am also a little fortunate that, things also, like the supporting things also came very well. For example, in terms of exams, in terms of CSIR exam, the correct timing of the results, and I got it without much difficulty. And so all those things also indicated me that, okay, what I am trying to do, the nature is also supporting. So those kind of things gave me the confidence that, this is something that I have to pursue in life. This is the thing that I am meant for. So this was a tough time, but with the surrounding support, as well as my own, I must also, the days that I had to pass through, it's not that easy, but I have to stay focused, and I try to get involved into as many activities as possible so that I can forget about these things. So that's how I got involved in this scientific conference that happened at Devra College. Generally, students don't get involved into it. I volunteered to the teachers that, no, I want to be part. I will take care of this. I will take care of that. And all these things. I was very much involved in this scientific activity as well. So conference active organization as well. So this is one example. Similarly, there was a there was an embassy tour. I took the entire responsibility and we went to Goa. And entire responsibility, train tickets, So basically, I was finding ways to get more occupied.
More important.
To come
Nice.
out of this kind of day. So I had my own ways of coming out of it. Once I saw that, the supporting system is also working towards that direction, that gave me the confidence. And then the moment I joined Professor George Thomas group, then the world was different.
World, exactly.
It was a different
story. Wonderful. The points what you made, two things very important. One is that you had a kind of a good friendship within your ecosystem, which is very important, the human connection. And second thing is what you mentioned is very, very critical, the way you took initiative. Because a lot of times opportunities come dressed as work, but if you are ready to do the work, you can see that the opportunities turn out to be.
So that was the first time that I saw the leadership in myself. Yes. Even though I was aiming for an army career, but I never realized that leadership. So these days when I could see that, yes, it is okay, I can do it, and that was a boost for me. Yeah.
So before we kind of, go further into the research career aspect, I want to get your inputs about one of the outstanding research places in India. Everybody who does chemistry will know this, and everybody who is interested in science should know this. There was earlier a place called as RRL Trivandrum, which is now NIST. Yeah. And it is, in my opinion, one of the best places to do research, period. And more so, it is probably one of the meccas of photochemistry. It is probably one of the great places. Of course, M.V. George, Professor George Thomas. There are so many, Professor Ajay Ghosh, so many outstanding, Suresh
Das,
exactly. So give us a very brief overview of that fantastic place. A long time ago, maybe about 15 years ago or so, I had also visited only for a few hours. In fact, you gave a talk there. In fact, very, very long time ago. It was a great opportunity and also an honor. Could you please just give us a gist about that? Because I also met Professor George then, very brief time. And anybody who wants to really know who is M.V. George, you should know it. He's probably one of the greatest chemists India had. Yeah. And a lot of people who have done outstanding work, like the lineage of Pramod and also Professor George Thomas, all actually come from that great kind of, school of thought of photochemistry. So paint us the picture, Pramod, because you have been a PhD student there. Yeah. And many people who have graduated out of that place have gone on to become pioneers in the photochemistry, and also many other parts of chemistry. Not only chemistry, there are other areas also. Just give us a kind of brief overview before we get into your own research aspect.
So as I've told, it was not planned. Nothing was planned. It happened that I entered into RRL, and that too under this photochemistry research unit. So that was the name, chemistry research unit. That was the PRU. That was the name of that department, and it was developed by Professor M.V. George. So after he retired from IIT Kanpur, he could have gone to anywhere. So there were a lot of, as you can imagine, he got a lot of opportunities, but he wanted to come back to Kerala and give his contribution to the state. So that is how we started this photochemistry unit in Trivandrum, in RRL, and he slowly built that. He was the first person there. Then he appointed Dr. Suresh Das, and then one by one he appointed different people. And he was a pioneer there. He was a true leader there. He used to mentor a lot in the initial stages. And since he was at IIT Kanpur, and since he had a lot of contacts in Indian and world science, that helped a lot to build the photochemistry unit. The funding wise, we could get good funding. And if you see the initial papers that came out of photochemistry unit, all these scientists were involved in the paper. So Ajay, George Thomas, Suresh Das, Gopitas, Ramaiah, Professor George, everything was there. And so that is how they collectively worked. At that time, no one worried that I am the first author, I am the author, nothing like that. They wanted to do science, and they wanted to prove that Professor George was right in setting up the photochemistry unit. That was the entire purpose. So this is something which is happening from 95 to 2000 or something. And once it was set up, I joined in 2003. So by that was the best time, I would say, of chemistry unit because all the hard work was already done. And as you mentioned about some legendaries who have come out of RRL, they were all seniors at that time, like Sri, Mahesh,
Mahesh, yes.
they are already there. They are all set up there. So we entered, I would say that, at a correct time when
Yes.
that department was established. And during that 5 to 6 years, if you see the output out of that particular department is huge.
Huge. Yes.
Constantly, papers will get published in high reputed journals, which was tough to publish at that time, and it
Yeah.
was happening consistently. And many new areas developed from there. So the photochemistry, I would say, took a different angle in Indian perspective, I would say, from this unit. And it was a privilege and an honor to work during that time. And again, we used to have everything was combined at that time. It was not, even though there were 5 independent scientists, we worked as a unit. So we used to have common group meetings, common quarterly presentations, where the professors start summarizing what happened in the previous quarter, followed by each student. And Professor George will be sitting there. He will be giving his suggestions. And it was like that. It was like one group. So we didn't worry about, okay, the sharing of idea or using of idea. Nothing was happening. So and all these 5 scientists had their own expertise. And they made sure that there was no overlap between these things. So that was very key. And Professor George played an instrumental role in that. He made sure that, we are not hiding anything. We are discussing everything. And these instruments, as you know, some of these instruments are very expensive and you have to maintain that. So as a student community, we were also one because we knew that if something happens, the entire group of 5 scientists is going to get affected. It is like that. So that is how we grew there. And talking about Professor George, he is very tough. He's a gentleman, one of the best human beings I have seen. At the same time, very tough, very, very, I would say, very strict in all the aspects, right? If you are drawing a line, that also has to be very as straight as possible. And one thing that comes to my mind now is the monthly reports. So we used to have these monthly reports, and since there were not enough computers available, it was handwritten. So, and now we have to, it is on a white page, we have to do the stencils, we have to make sure that it's straight line. And when we draw the benzene rings, because some of my PhD research included synthesis of organic materials, so benzene ring, all the 6 carbon, that bond length had to be same. So we used to do it in stencil, Professor. And once we submit this monthly report, Professor George will come and sit in the lab, and he will be correcting our monthly report, and we will be doing the experiments. So we are always under the pressure that, again, now we will hear Pramod, what is it? Something like that. So that was, so that is how we had an impression about him. But he was very sincere. And other thing is that from all these things, he didn't gain any person. He was not involved in any of these papers after a stage. He allowed everyone to work independently, and he gave whatever facilities required. And I think, that he was selfless in that aspect. So he made sure that the science is growing rather than the people, in fact. And he made sure that the students are also going for a postdoc. And it's been finished, it's been completed on a reasonable time. And there is no problem of funding. So that was a sweet time, that 5 years that I was there at RRL Trivandrum. That was, I would say, the best time that we had, and the support that we got from Professor George and all other 5 scientists was immense. It was amazing. So that is how.
Undoubtedly, because you can see the people who have kind of graduated from that place: Mahesh, Hariharan, Subhi George. They are really, so many of them. There's so many. I'm just naming only a couple of them, and I myself have seen that that culture of thinking through the process, that fundamental kind of foundation, what is there in all these people is outstanding. Which also brings us to another important aspect, which is a very critical aspect of your PhD, was that you and of course Professor George Thomas were one of the first people to also do a systematic work on plasmonics from slightly more from a chemistry and also materials viewpoint. I'm not just talking about India, but also across the world. I'll come to one of the papers which I always keep telling to Pramod about. There's a very, very nice and fantastic paper written by Pramod and Professor George Thomas in Advanced Materials about the dimers of plasmonic nanorods. which I'll anyway link in the show notes. Tell us about that background of how you people started that work, because it's still one of the most relevant works which has been part of the literature in plasmonics. It has motivated so many questions, the concept of antennas, and that really needs a lot more attention than what people have really given in talking in terms of generally. Of course, the literature already tells that that paper is highly cited and also very highly valued. And I, as a postdoc, also I used to read that. That's how I have registered that particular paper. Tell us about a little bit more about that work, Pramod, and also generally your PhD work. Yeah.
So, as I've told, in this RRL, when this photochemistry research unit was developed by Professor M.V. George. So the focus was to do the photochemistry of molecules. And Professor George is primarily an organic chemist. So initial systems were all molecular, organic, molecular, inorganic, or complexes-based systems. So around 2000, I think Professor George Thomas had an opportunity to visit the University of Notre Dame in Professor Prashant Kamat's. That is where, this idea of nano, and those were the times when the nano thing was becoming more and more popular. And but I think our group was one of the first to do a lot of physics and photochemistry on nanomaterials, especially plasmonic nanoparticles. So that is how Professor George Thomas got interested in this area, and he decided that, okay, I should also try to study this work. So if you see the first JAX paper he published independently, that was on an organic, photophysics of an organic molecule.
Yes.
And later he transferred to the
nanomaterial thing. Yeah.
So that is how he started the career. And at that time, I still remember there were two seniors. And to one senior, he gave the PhD program that, so we will be doing on optical properties of nanomaterials. Now, during those days, you have to give the summary of each chapter. What would be the content of first chapter, second chapter, third chapter. So I still remember. So this I came to know after I joined It's a famous story in our group. So what they planned is that first is the introduction to nanoparticles. Second will be optical properties of gold nanoparticles. Third chapter will be optical properties of copper nanoparticles and silver nanoparticles, because they didn't know that, you need to. So that was the overall theme of it. But now if you see, till this date, he's still working on gold nanoparticles.
Yes. It has turned out to be one of the most important areas of research, right? Yeah.
So that was, that is how he entered. And that student, his name is Binil Ittai. And he went for postdoc with Mounzi Bhavanti, who got the Nobel last year. So he was the first PhD student who worked on nanomaterials, especially gold nanoparticles. And after that, after a couple of years, I joined the group, and I could continue this thing in nanoparticles. So one of my first projects that they gave was to study the photo-induced electron transfer from a chromophore to the plasmonic nanoparticles. That was my target. And so that chromophore was a ruthenium trisbipyridine based chromophore, which is rich in electrochemistry and photochemistry. So I have to chemically attach it on the surface of gold nanoparticles. So that was the target that I was given. And study the energy transfer or electron transfer and try to see the charge separation dynamics. And because none of this information were available at that time. Was new at that time. So that is how, so my first couple of years of my PhD was just to make that molecule, attach a functional group on the surface so that it can be attached onto the gold nanoparticles. And our idea was to change the distance between the chromophore and the nanoparticle. The spacer length, we need to change it so that, we can study the effect of spacer length on the electron transfer or energy transfer process. So that was a project, but it was so difficult to attach this ruthenium trisbipyridine chromophore on the surface, because the synthesis itself was challenging for us, because it involved traditional organic Sonnegaster coupling reaction. The traditional, organic synthetic reactions were there, which you have to do at low temperature and with highly reactive reagents and all. So that skill I got during the synthesis. And finally, after I think it was around 2.5 years or something, I could finally make that molecule, characterize it to all the techniques possible. And finally, I could attach it on the surface of the nanoparticles. It took me around 3 years to reach that stage. And in between, I was trying many things, different things also I was trying. In case it doesn't work, you should have something. So I would say it took around three years to get a working system. And once I had the system, then the photophysics was straightforward because we were expert in photophysics. We knew how to monitor energy transfer. We knew how to monitor the electron transfer. That was well known at that time in our group. In the photochemistry group, we had all the facilities, transient, nanosecond flash photolysis, everything was available, lifetime instruments, everything were available there. So we knew what to do once you have a system. But to get the system, that was a challenging part. So once I had that, then this work really went through, and we could see the effect of spacer, and so many interesting things came out of it. We also we also studied about the crowding effect of chromophores on the nanoparticles. So when the density is more, you see that the photophysics is changing. When the density is less, the photophysics is different. So all those kind of things which we didn't plan or anticipate, that all came out of this particular project. And that was the time when I also got introduced into these nanoparticles. And we also had nanorods project working in the group. One of my senior person was working on the nanorod, and he was trying to do this plasmon coupling. Again, like it's Binility, that senior that I was talking about, Binil himself, he was trying to do the plasmon coupling, and he could do it in the presence of some amino acids and something like that. So that is the first time when we also learned about the plasmon coupling, like when two particles come and interact with each other, what happens to the plasmon band. It can be a good beyond a sensor. From a chemist perspective, it is just a sensor, but beyond the sensor, it has a lot of physics involved in this in terms of interaction between two nanoparticles, plasmonic rulers. Those new things started to of that particular word. So what we were doing, and we were able to get at that time, is that once the process is basically a self-assembly process, just bringing particles close to each other. And we will, with respect to time, we are getting chains. So that is what the skill was available at that point. So at that point, we asked the question to ourselves, mainly Professor George Thomas asked me, can you control this self-assembly process? Can you make sure that, you get a dimer or a trimer rather than getting, 10 nanorods in one go? So can you do something about the kinetics of self-assembly process? So that was the question that we had. And that is how, we ended into that project. And we realized that by playing with the concentration of the aggregating trigger, or by looking at the flexibility of the aggregating trigger, we were able to control the self-assembly process. So under an optimized condition, we were able to see the dimers. And these dimers were stable for quite a good amount of time, so that if you want to do some study, you should be able to do it. But that was a proof of a concept that, by playing with the kinetics of the self-assembly, you will be able to control the order of self-assembly and all those things. And one other thing that came out of that project is this angle between the things. That also we were able to, this was not under our planning, but we saw that when we are using some specific ligands, we are seeing that the angle between these two nanorods, when they come close, that is also changing, and that will have an extent on the plasmon coupling. So that was, and there was a theoretical work on that, like if it is like this, by L side, if I am correct.
Yes. Yeah, even George Shaz also had some.
Shaz also, yeah. They had a lot of theoretical works on that. Yeah. It was an experimental proof that yes, you can indeed see this dependence angle on the plasmon coupling. So that work was, I would say one of the best works that I have been involved so far. And then later, we were, since that was how I entered into nanorods from nanoparticles. And then, then obviously I need to get one more chapter for my thesis. I thought, can we have both nanoparticle and nanorod together in a system? Can we do that? So I know how to work with nanoparticle. I know how to control nanorods. So I thought, can I do some interaction with that? So that was a point when we realized that there is a big fundamental difference between a spherical particle and a rod, which is shape anisotropy. And because of the shape anisotropy, there will be a lot of difference in their property. And one of the properties is the edge effect. Since these nanorods, so all this electric field will be more concentrated at the edges of the nanorods when compared to a nanoparticle, where it will be more or less uniform. So we thought that if you just mix nanorod and nanoparticle, will the nanoparticle selectively go to the edges of the nanorod rather than the uniform distribution? That was our question. And there also we took the help of this capping ligands and those things to control the self-assembly. And we found out that it is preferentially going at the edges of the nanorods. So we were able to make, this kind of satellites specifically at the nanorods. And I think that was a very good work, I would say. And so this was my PhD. So it was basically on photophysics and the self-assembly of nanomaterials and its impact on the plasmonic properties. And in all processes, there is a plasmon coupling happening. So this can be good material for SERS, for sensors, enhancement effects. So it's for multiple things. As you told in the beginning, it can be used for multiple things. So that is how my PhD is there and how we started to work in nanoscience.
Wonderful, wonderful. That all these things also culminated into you being awarded the Humboldt Fellowship as a postdoc, which you took up to go to Technical University Dortmund, and then subsequently you went to also US in the Northwestern University. How was your experience of these postdoctoral stints? Just give a very brief gist of in which group were you working on, what kind of problems you were looking at.
So my PhD was mainly on the photophysical aspects of or the chemistry aspects of these nanomaterials. And and one thing that came to my mind during the end of my PhD is that these nanomaterials can also find applications in biology. These are all plasmon rulers, optical sensors that we are talking about, that can be also used in biology. So I wanted to try the biological properties as well. So that is how I applied to Germany. So that was a chemical biology group. It was a chemistry group. It was more like a chemical biology group. And so I applied under Professor Christoph M. Niemeyer. He is a well-known chemical biologist. And he works on DNA, cells, DNA nanotechnology, if you remember, during 2000, DNA nanotechnology was a fashion at that time. So it's very important area. So that motivated me to see, okay, can we do some bio-related properties of nanomaterials? So I applied for Humboldt, and my PhD output was decent. So there was good support from my CV as well. So I was lucky to get the Humboldt fellowship, and when I went to Dortmund, and there we were working on doing this nano quantum dots. There I started to work with a material called quantum dot, because the project which we applied was for tagging the live cells. So can we tag live cells with quantum dots so that we can use them as an imaging? Quantum dots have a very bright luminescence property. So can we just introduce it into the biological system and try to tag this so that, by changing the surface chemistry of the quantum dot, we may be able to have the selectivity, like for example, between a cancerous cell and a non-cancerous cell. So something like that, can you use it as an imaging agent? So there it was a lot of biological things that I had to do, like I had to attach DNA on the surface of the quantum dot, which is not an easy thing. But somehow these biomolecules didn't work well with me. Because that requires a separate skill. A separate skill. You have to do the gel
electrophoresis,
and FPLC. It's a complete skill that I knew from my PhD days. So, but it was very challenging, but still we could demonstrate decent properties of quantum dots. And so that was my first postdoc in Germany. And after that, in my second postdoc, I went to Northwestern University in Chicago, where I worked in a group of there was a center which was supported by DOE. And this was called as Non-Equilibrium Research Center. We call it as NERC. So there were a lot of scientists involved in that, and a professor named Bartosz Grzybowski was the head of that center. And we had, so many, for example, Chad Merkin, many people were, Stoddart, everyone was part of this kind of this consortium kind of a thing. And so there was a postdoc. So from Germany, I went to a Gordon conference in Boston. So at that time, I was lucky to hear Bartosz Grzybowski giving this talk. And at the end of this, and his talk was fantastic. Amazing.
He's an amazing speaker.
Amazing speaker, and many new things which I was not aware at that time. I got fascinated, and towards the end, he told that we have a big funding in the form of this center. So if you want to, if some smart brains are in this crowd, please come and interact with me. So that is, then I thought, okay, chalo, let's try to. But he was so occupied and so crowded with other people that I could not find a time to meet him. Where whatever attempts I had, he's always occupied with someone, and I could not wait. I could not find him. And one day, as you know, in Gordon conferences, everyone sits at one place, breakfast is together, everything. It's one of the best conferences, I would say, that
Absolutely.
I have. And in one of the breakfast times, we were all having breakfast, and it was completely jam-packed. And Bartosz comes a little late. So there was only one seat which was available, which was adjacent to my side. Again, the seat thing is coming. And he comes here and he asks me, Pramod, no, he didn't know my name. He told that, is this available? Then, please have. Then he asked me, where are you from? Then I told him, coming from Germany. I'm from India. Then he told, okay. Then I told, your talk was fantastic, and you announced about the postdoc positions. I'm really interested to avail that opportunity if it is available to me. And he told, okay, so what can you please tell something about my science? So what I'm saying is that I was trying to reach him the first 2 3 I could not get him, and then something
he's come to you.
I told about my work about that edge effect, the nano rod. They remembered that POC. Oh, that is the POC where you have nano rod and this particle. Wow. Then he remembered, oh, you were that person. Okay, then yeah. Then he told, do you have a poster? Then I told, yes, I have a poster. So please show me the poster. So my poster was supposed to be on the next day, and he won't be available. He's going that night. So please show me in the night. Then in the night, I just went with the poster. I showed him, explained everything. He didn't ask any question. He only asked one question: are all these your work? I told, yes, it is. At that time, he offered me, okay, I'm selecting you. You come to the postdoc.
Wow.
My secretary will contact you. Everything was decided on that particular moment. So
amazing.
So it happened, and then I reached Northwestern after maybe 6 months or something. And then there it was a completely different situation for me, because in India I had a different skill set. And in Germany, my skill, the learning experience that I had was going into the depth. They will have one problem and they will go as
drill it.
Really, that was the experience. And when I came to his group has complete diversity. He has physicists, he has chemists, he has biologists, he has theorists, engineers. Everyone is there in his group. And at that time, I think there were around 35 postdocs or something.
Wow, okay.
And a good number of PhD students. It was a big group. And in the group meetings, I could not follow 90% of the stuff that students are telling, right? So diverse. So that is the place where I learned that, you can also learn many things at the same time, maintaining the depth that is essential to understand that particular project. So that was I would say, fantastic experience for me. And that changed my perception about the science. And also it gave me a lot of confidence, because Northwestern is a place where you can do anything that you want. There was a lot of funding with him. He never told me, and for that matter, any of my supervisors told no to anything. When I tell that I want to buy this for so-and-so project, yeah, please go. I never heard no that, okay, we don't have money, or it's too expensive, it is not worth buying it. So that was a freedom I had throughout my career, like when I was a student. And then at Northwestern, we had the access to all the facilities. 24/7 facility is available. And you can, for example, TEM, you make your nanoparticle within whenever you will come to know whether you got the desired size or not. If not, change it. So fast, and I enjoyed my stay at Northwestern. It was very tough. He's a very tough person. And I only interacted with him during the group meetings. He's so occupied with other activities, and he's publishing he publishes a lot. So he's always occupied with papers and projects and everything. And I was doing my second postdoc, so I cannot expect him to support and interact with me. So I also took that as an opportunity to, again, be independent as much as possible. So the projects that I worked there was very interesting. Since he knew that I have some expertise in nano rods, he gave me this challenge that, can you make a bimetallic nano wire? So he told that what he is looking for is that when you have a bimetallic nanowire, which has two different coefficients of thermal expansion, and when you heat it, one will expand, the other one, the expansion will be different. Now, the challenge that he gave me is that, but I want you to make it in such a way that you have one metal like this, and the second metal should be like this. not
Hmm.
uniformly. It should be like side by side.
Side by side. Okay.
Now,
Okay.
if I
Nice.
take
Nice.
this material, instead of expanding, it will try to bend it.
Bend.
Because this material will be expanding more and this material will be expanding less. So what you will end up is with a bending. And when you bend something, as you can see, and I am bending my finger, you will
Mm.
see that the inside atoms are getting exposed.
Nice.
Now I
Nice.
can use it for many things, like for example, catalysis. And when the
Mm.
catalysis or my property of interest is over, I can remove the heat source and it will come back to the initial
Come
state.
back.
So
Nice.
this was the idea that he gave me, can you make a material like this? So, and I don't have any background of such kind of techniques, how to make it. And I basically know how to do solution
Mm.
chemistry. So this was requiring fabrication, solid state things. And also it was as I've told, whole facility was there. And that is where I learned about this thermal evaporation
Mm.
techniques, because you have to evaporate it. So we grew these nanorods. Gold nanorods were like this, and then we had a glancing angle deposition of the second metal, which was copper in
Nice.
this case. And in that case, you will get that only one side of the gold nanorod will be deposited with copper. Then so that was how I made the material. And I think he was impressed by that, because he also didn't think that, we will be able to make that
Make
material.
that.
It's also published in Advanced Material. And those the images are beautiful. You get a uniform deposition only at one side of the nano. So it was
Nice.
in a macroscopic scale. So that was, but we could not get the result that we wanted. That bending could not happen,
Mm.
because the next step was to disperse them in solution, which I could not do efficiently. So they were in that substrate itself. But then we did some other studies like, dielectric breakdown and all those
Mm.
studies, because the spacing between this nanorod was controllable. So we had a dielectric material between that, and we gave the voltage, and we studied at which voltage there is a dielectric breakdown.
Directly.
Circulation of electrons are happening between the nanorods. So that was a different project, but that was a project that I did there. And then, then I could do anything that I wanted. So still that
Mm. Mm.
biology aspect was still there with me. So I did a lot of biological studies also with our nanoparticles there. And there we worked with what we call it as a mixed charge nanoparticles. Generally,
Mm.
people attach only one type of a ligand. We started to attach two types of a ligand and try to see how they are going to effect in the biology kind of thing. And we did a lot of cellular uptake studies, antimicrobial studies, and everything. So we made, what we call it as nanobiotics. So
Mm. Mm. Mm.
antibiotics, we made some nanobiotics, which was very selective to a particular bacteria, depending on the surface chemistry of the nanoparticle. So that experience was very good for me. I was there for 3.5 years. And I could learn a lot of things, starting from, material synthesis, electrical properties. And we also did a lot of magnetism studies with this kind
Yes.
of
It
materials.
culminated into even a nature paper, right? That is,
Exactly. So I was part of that work,
yeah.
it's amazing. That idea was amazing to work under this magnetic molds that
Molds. Yeah.
try to have. So it is an alternative to optical tweezers. That is what
Absolutely. Yeah. Yeah.
in
Yeah.
that work.
In fact, there is a very rich history of Bartos group working on self-assembly. There's also famous paper with white sides,
White size,
self-assembly at all
full
scales. That is one
scales.
of the outstanding papers. In fact,
Exactly.
it's a lot of.
So,
So, Pramod, this is actually, this experience of starting with plasmonics, then going into, let's say, nanobio kind of area, and here also looking at, let's say, a self-assembly process, etc. All these things culminated you to now gather, all the focus, and then plan to come back to India.
yeah.
First question is, why did you come back to India?
Mhm.
Second question is, how did you come back?
The first question is why I came back to India.
Uh,
So when I left India after my
mm,
PhD, I'm sure that I will come back. That was
mm,
something that I promised to myself. Maybe
mm,
because of the background that I
mm,
experienced in the beginning, I wanted to come back to India. That was there was no doubt about
mm.
it. But when I was at Northwestern and when I completed my 4 years of postdoc, so that is a time when I started to apply. And I realized that it is not at all easy to get a position in India. I think and vote for that. It is extremely different. The competition is amazing, unbelievable. And so it was very difficult for me to get a position in India. And I also reached a situation where I was forced to apply in US,
Mm,
which
mm,
was not in my plan. So I had to apply for some GE company, some 3M companies.
Oh, okay. Okay.
I applied for that, but I was very close in getting the job. But since I didn't have this green card,
Green card. Yeah.
one problem that I faced. And then, I applied at many places in India, and some places I get the response, some places, as you can see, as you can know, no response, you don't know what is happening. So then I thought that, okay, let's try to settle in US itself. Let's try to apply for a green card and, try to get some job. Then the job chance will also be higher if I
Mm.
green card. But again, my fellowship was not that great, and I
Mm.
had a family and a small kid at that time. So the fellowship was not enough to apply for green card and everything. But my friends told that, okay, they can support. And so I was in that plan. And then I wanted, since my tenure in that Northwestern University was also coming to an end, I needed some other position. So I applied to Harvard Medical School.
Mm.
Because that is one, as I've told, the
Yeah.
biology in nano is always in me. So I thought that, okay, let's try to think in that Harvard Medical School. And I was there for the interview, and I was about to get a position. And that was a time when, one of my applications, I was called for the interview.
Mm.
So before that, what happened, I think in 2012, after 2 years or 1.5 years in US, I came to India to give an interview in RRL Trivandrum, the place where I did PhD.
Mm.
There was a scientist position available, and but I could not clear that interview. And at that time, my CV from postdoc was not that great. I had only 2 papers, I suppose, from my postdoc. So I think it was not that strong, and I could not get the job at RRL. And after that, during that time, Professor George Thomas helped me to get a talk slot at IISER. So
Okay. Okay.
during that visit, I contacted Professor Ganesh through Professor George and Professor Emily George, sorry, Professor George Thomas. And then Professor Ganesh was kind enough to give me a slot. And then I gave a talk at IISER Pune in Mendeleev building.
Mendeleev, yes. Yes.
Building, I gave the talk. And Professor Ganesh told that, yeah, everything looks fine. But once you feel that your CV is good enough for application, please apply. So that was a thing that he told. There was no job assurance or anything.
Yeah. Yeah.
My CV, as I've told, my CV was not that strong from postdoc. The PhD, I think it was still good.
Yeah, it was.
Postdoc, it was not enough. Papers were not coming out. And then I came back to US. And then after that, once I had the good papers from my postdoc, I started to apply at multiple places. There is one place called INST Mohali.
Mohali, yeah.
IST Center. I think that was the first recruitment that they were doing. And Professor, I think Ashok Ganguly was the director at the time. And I was called for interview, and I gave the interview online from there. So that was a online interview that I gave, and I got selected there. So then I thought that, okay, at least I got one job. So now I don't have to go to Harvard Medical College, because that is also not a guarantee, right? After
Guarantee,
that,
yeah. You'll again have to go and check.
Exactly.
Yeah.
I wanted to come back to India anytime. So that was my thing. So then parallelly, I gave the talk at IIT Kanpur also. And as you know, when you are in US, the visa issue is a big thing. You cannot tell like whatever you want, right? So I told IIT Kanpur people that I can't come physically to give a talk. Then they were also generous to arrange an online talk. So before all this COVID all started, I gave the online talk in a department in IIT Kanpur, and it was very effective. And I think I understand that they were also processing my file. But by that time, I got the job in INST Mohali. So I was, and in between, I also applied at IISER Pune, but nothing was happening. So I wrote to IISER Pune telling that I have got a job at INST Mohali, and I am planning to resettle in Mohali. So I'm coming. So is there any update in the status of my application? So no, nothing came. And I was just starting from US. And on that day, I got a reply from IISER Pune telling that your interview is fixed on. You have been invited for that interview. And I came to India one day before that. So I just I booked all my tickets, because I know that otherwise I would have come directly to Pune. But since I didn't know, I went to my hometown, like in Cochin, I landed. And within few hours, I had to take a flight to Pune. So you should imagine, like when you come out of US, you have so many things to do, right? All the things you have to ship or you have to sell it. It was a hectic thing. And then you land here, and the next day I have the interview at IISER Pune. It was, I think, Monday. I still remember it was a Monday. And I came to the guest house. And so they told in the beginning that it will be in the morning, the interview will be in the morning. So I was all ready. So Mustafa was there, Jnana was there. We three were there for the physical, and there were 5-6 people who are appearing online. So we three will be giving the interview in the morning. That is what we were informed. And by 9 o'clock also we were ready. And then they told that no, first they are going for the online people because there are some people from US and
yes, yeah.
they have this. Then I was so tired that jet was there. You won't believe me, Pawan. I slept in the first half.
Oh man.
The interview day of a job interview at IISER Pune, because I could not control myself. I just slept in the morning, and in the afternoon I just woke up and Jnana Prakasham saw me. Oh, you're sleeping on a day of interview. So it was like that. And then we had the interview at Professor Ganesha's residence, the Ganesha's residence, and that interview, I would say it was okay. I won't say that it was the best interview that I gave or best presentation that I gave, because I was also completely exhausted. But somehow I think I got that interview might have been good, and that is how I got the job here. Then I politely wrote an email to Professor Ganguly, the director of telling that I got it here, so I have decided to join. So that is how I ended up in IISER Pune. So I would say that it was close to, it was a last chance, or it was at the brink that I got the job.
Wonderful. Fabulous. Wonderful, Pramod. So also tell us now about the current research interests you have in your group, and also give us a gist of the projects, what you're working on. And so that we get kind of an overview of the work, current overview of the work.
So so I had big plans when I applied at IISER Pune. So the proposal was, lot of fancy projects where, as you can imagine, right, you are coming from Northwestern and 5 years abroad, so 5.5 years abroad. So you feel that, and at Northwestern, I was able to do whatever I wanted. So all the projects were designed based on that. And IISER Pune was not relatively new, but it was not that new, but relatively new place. And I thought that, there are a lot of things I could also bring as an instrument, and I could develop many areas. Yeah. So there's one big project which was on nanobiotechnology. And after I came here, one good suggestion that I got from Professor Ganesh was that, all your projects, everything is fine, but just look around the facility that is available at IISER Pune and try to have projects B, C, D kind of thing, So by the time it's clear that project A is not going to be implemented here because it would be difficult. So then I looked into all the facility that is available in the department at IISER. And if you remember, we didn't have TEM at that time. So I could not do much with respect to new material design or characterization. There is a limitation. And the materials that I work are in the nano dimensions, like 10 nanometer, 5 nanometer. So SCM may not be good enough to study those things. TM would be better, but that facility was not there. So I realized that, and the biggest realization was that some of the chemicals that we were using in US, unfortunately, are not available in India. So this entire project will not work like that. So then I had to revamp all my projects, and that is where I would say that the diverse expertise that I got from my PhD, first postdoc, second postdoc, came to be very handy. So now I had at least some basic knowledge to design a project. So that is how I designed the. So first of all, I want to have a project which was little safe, so that in the first couple of years I can get the initial results, the publication, so that students are also comfortable. So first project that I designed was based on the self-assembly itself. And there I was interested in the controlling the thermodynamics and kinetics of the self-assembly process, which we call it as non-equilibrium self-assembly. Generally, people talk about equilibrium self-assembly, but the biological things are all non-equilibrium self-assembly. So we were looking at the dynamicity, transientness, and all those things. So that project didn't require that kind of an instrumentation. You can monitor the self-assembly process using UV visible, and at some stage you can take TEM or SCM. So most of the things we could do in the department itself. So that was the first thing that we did. And so basically it was a non-equilibrium self-assembly based on plasmonic gold nanoparticles and plasmon coupling and all those things. So it was pretty much an extension to what my expertise was. And then slowly we started to work on quantum dots, different type of materials. I got the confidence, and when more students joined my group, I had this quantum dots and different type of materials that were developed in our group. And slowly And then the second skill that I brought into my independent group was the photophysics, because that is my bread and butter. That is where I have the training. So we did a lot of photophysics in quantum dots. So during my PhD, we were doing it in plasmonic gold nanoparticles. So we started to do it in quantum dots. And one of the things that was in my mind was that I don't want to work with the conventional quantum dots, which are cadmium, tellurium, and selenium based. So I wanted to have a little bit more environment friendly. So we selected the material like indium phosphide. Is much less toxic when compared to the traditional thing. And fundamentally, they are different. They are the different class of quantum dots. So the energetics and the binding energy, everything is different when compared to cadmium selenide. So those were the projects that we initiated in the beginning. So it was basically focused on self-assembly and photophysics. Photophysics.
Nice.
That was the initial, I would say, 3-4 years. And then we realized that some of these materials can be good photocatalysts. So this catalysis is something that I was not trained at all. I had zero experience in catalysis. So that was a big step, I would say, or a big decision that as a project leader, I took that let's try to do it in catalysis. And there also, I didn't want to do just catalysis. I wanted to develop a hypothesis for a catalysis so that, I can do any reaction. So I promised myself that I will never focus on a particular reaction, because if I focus on a particular reaction, then it will be more focused on that. More than that, I wanted to develop a hypothesis so that it can be applicable to multiple reactions. If I need a reaction, I can implement that. That was the idea that I had. So I was thinking at that time, so what was happening is this, as you know, these nanoparticles have a lot of ligands on their surface. And these ligands are most of the time, organic molecules, which are insulators. So they don't allow this electron transfer to happen from the nanoparticle to the reactant molecule. We call it as ligand poisoning. So that was hampering the area of nanocatalysis. So I thought that can I use my knowledge of surface chemistry, ligand chemistry to facilitate the catalysis? So we came up with what we call it as favorable ligand. It's something called catalyst reactant interaction. Can I use my ligands as a tool to control the interaction between the nanoparticle and the reactants? Again, these electrostatic interactions, hydrogen bonding, all these non-covalent forces we implemented in the project, and we were able to regulate the channeling of the reactants close to the catalyst surface. So then we could see that, even if you have a ligand, you can do efficient catalysis.
Nice.
And,
nice.
It was basically ligand. We were using ligand as gatekeepers for catalysis. So that was the first time when I realized that, ligands can regulate the properties of nanoparticles. And from that day onwards, we were more focused on ligand-gated photophysics. And this can have impact in energy transfer, impact in electron transfer, catalysis, all these things. So that catalysis, and we are doing photocatalysis. So it is, again, in a sustainable way, light matter interaction, lot of spectroscopic tools, and most of the things were available at that time for me to do the initial studies. So that particular project, I am very happy that I would say seeded from IISER Pune. So I had absolutely zero experience or expertise, and learned from my students. So the students were the first to learn, and then they taught me. So this area is now moving well, and this hypothesis of ligand-gated catalysis, now I can use it for any reaction that I want. I just have to find an appropriate ligand so that the catalysis is favored. So that is the hypothesis that we have developed. And the later part, we realized that, not only the electrons, but the heat also can be used from a particle. Because, upon photoexcitation, as you know, it's not only that the electron, but heat is also dissipated in some classes of materials, especially plasmonic nanoparticles. The heat dissipation is the most prominent and feasible. Now we are starting to, and this we call it as thermoplasmonics or plasmonic heat. And now we are using this plasmonic heat to drive chemistry. So we have realized that, the temperature that you can get from this plasmonic heat is huge, something like 250 degrees centigrade or 300 degrees centigrade. And with that temperature, you can do fantastic chemistry. So now we are also focusing on the heat component of light matter interaction, which generally people consider as a waste.
Absolutely.
Now we are trying to generate electricity out of that heat.
There's a recent nanoliter paper also, which is coming out from your group. Very, very fascinating piece.
So basically, my research, to sum up my research, it is like light matter interaction of the nanoscale focused towards a chemical change. Initially, we started with electrons. Now we feel that heat can be also used. So this is
wonderful. So you've also been training very good students, and I see that you have also had very good group members who have done very good work. Many of them also have now gone into other pastures
Yes.
explore other aspects. And what are your kind of futuristic plans and kind of things you would want to move, or not very specific aspects, but general kind of directions which you are interested in? What are the things you are looking forward to?
Yeah. So talking about students, I must say that
Mm.
I was lucky to get some of the best brains that,
Mm.
was available for me. And these guys, and as you know, when you have a new group, it all depends on the students. You may have fantastic ideas, whatever you have,
Yeah,
and
yeah.
these are the students who are going to make it work. So I was lucky that in the initial years, the students who joined my group, they were amazing. They were, completely interested in science, and everything was new for them, new for me to some extent. So they were, I would say, I learned a lot of things from them.
Mm.
Now, most of them are doing well in life. They are still in their postdoc stage. They are 3 years that they have left my group. So I hope
Nice.
they will be ending up in good places, independent career they may be able to pursue soon. And their CV, I am happy with their CV. Their skill set, they have expanded their skills
Yes.
after my PhD. And they have worked with some of the big people in this area. So I'm happy that, their CV was strong from the PhD, and I expect them to get into independent positions soon. So this I'm happy. And one of the students, I must say that he also went to industry.
Oh, wonderful, wonderful. That's an
And he
important
went
thing.
to,
Yeah.
I went to industry in GE company, I would say. His in Narayan Chakrabarti. And I think there they are working on flight engines and everything, how you can increase the efficiency of. So he worked on quantum dot photocatalysis. So somehow the industry felt that, this his skill may be useful for them to
Useful.
increase the efficiency of the engine and everything. So people are going into different directions. And I also made one thing sure that, no two students at a similar time working on similar projects. So I didn't want to have an inter competition between themselves. So currently we have 4 different projects, and there are multiple students who are working at 4 different. So when they apply for a postdoc or for a faculty position, I hope that there won't be any inter competition. And as you can imagine, it's difficult to manage all these 4 projects because write papers, the introduction is but this is something that I promise myself that I should have as much as diversity as possible, so that students are not getting tagged that okay, this is a photocatalysis guy, or this is a self-assembly guy. So I want them to be having a separate skill so that it will be useful in their time. So that was my plan for the projects and the future things. I would like to continue with whatever I am doing with respect to this photocatalysis, because now we are doing, so the initial 10 years of my career, as I have told, we were developing the hypothesis for nanocatalysis. Now we have the hypothesis in place. Now we would like to use it for important reactions like ammonia synthesis. So can we find an alternative for the Haber-Bosch process? Can we use sunlight to convert nitrogen to ammonia? So this is one project that is we are really interested in. Similarly, carbon dioxide oxidation. So all these things, we believe that our ligand-directed catalysis would be an approach to target these things. So this is a catalysis part that we are looking for. And from the heat perspective, we would like to use this plasmonic heat in thermocatalysis, because the thermocatalyst requires high temperature. So can you get that temperature from nanoparticles upon photoexcitation? And can you transfer that temperature to a thermocatalyst and do the reaction in a much lower temperature or a more? So catalysis is one area that I would like to definitely pursue. And along with this, I'm also interested in the luminescent properties. So recently, one of my students, Pradyut, has developed this blue emitting indium phosphide quantum dots, which I believe is one of the few examples that is available in literature.
Yeah, blue is very, very, very unusual, right? Yeah.
So we have got that, so we would like to do pursue with that as well. So it will be mainly, catalysis, basically light matter interactions for chemical change.
Chemical change.
It's
wonderful.
I would like to pursue.
Wonderful, Pramod. This is actually such a kind of also an area which is both of fundamental importance, because there are questions which are yet to be addressed at the core of the topic, and has also immediate application, because there are so many questions connected to this in terms of processing of energy. And it has turned out to be probably one of the most important areas now, because there are a lot of questions to be looked into. Thank you very much for a wonderful overview of the whole kind of progression of thoughts right from the days on which you actually sat with Professor M.V. George, all the way to doing some outstanding work. So I wish you and your research group all the very best, and I hope we'll also have this conversation, because in emergent series of Pratidwani, the plan is to also talk to people who are doing very interesting work, and at some point of time we'll also elaborate on some specific questions related to your research and other things. Yeah.
Definitely. Thanks, Pawan, for having me. I really enjoyed it. Nothing was planned, but I think it turned out to be a good time for me as well. I could recollect.
Yeah. That always is a very interesting thing, because that going through that memory lane would always bring in so many thoughts, which sometimes you would not sit down deliberately and think about it.
Exactly.
And this is actually, and this gets also kind of registered, and I hope a lot of people, including a lot of students, will get motivated from all these things.
I hope so.
Yeah. No, it is truly actually a wonderful journey. There's, as I keep telling, always there is a lot of things to learn from anybody who has actually gone through the process.
Yeah, I must tell that, even though this was not a path that I selected, but I am thoroughly enjoying it, because as I told in the beginning, this is what I was meant for. Only thing is, it took me some time to realize that this is my passion. And this group activity that we do as a group and everything is amazing. That joy you get anywhere. So I'm so happy that I ended up here. So I'm
wonderful.
This platform for and use, especially digging out all the good memories that I have, I feel so delighted now.
My pleasure, my absolute pleasure. So yeah, with this, we'll conclude the conversation. This is Pratidwani, where we try to humanize science, this time with the one and the only Pramod Pillai. Thank you, Pramod.
Thank you, Paul.